Hello, class. Today I would like to go over chapter 4. Chapter 4 is kind of long. So there are 6 sections. So I hope I can finish within 2 hours. So for chapter 4, you will learn how to we'll learn about graphing. Like you know how to graph, look at a graph and tell the equations, how to write an equation, and like some kind of detail about a graph and the inverse function of trigonometry and some inverse function of a linear function, quadratic function, but mostly we're focusing on trig function. So for 4.1, as you notice, we will go over basic graph, and 4.2, you learn about amplitude and period, about trig function. So I'm focusing on sine, cosine, and tangent, but mostly will be sine, cosine. Phase shift, you learn how to look at a graph, move up, move down, move right, move left. But all of this, you only need to know the basics, okay? And 4.4, finding an equation from its graph, which means you look at the graph given and then we learn how to write an equation. And graphing combination of a function. So for this section, like we combine maximum is only 2 function, the graphing, and then combine them together. And inverse function will be 4.6. So now let's start. And I'm sorry to mention you that I have created a note for chapter 4. It's not really like everything. However, it's mostly the main idea. I'm not open yet, but I will when I finish chapter 5. And for here, chapter 4 notes, you also look at this because all of this will be very helpful for you. Let me see what happened here. Okay. And I open up, then you will see the file look like this. So I combine all section within this file, so it's kind of heavy. And you should look at this ahead or when you do the homework, okay? But for this note, you don't have to take note and submit to me. This is extra. You only need to submit your note from the lecture, which is we're gonna watch over the lecture right now. Okay, so this is just extra for you. Okay, and I think it's very helpful. So for you to practice and do homework. Okay, so let's go back to the lecture page. 4.1.
Next, we want to look at some of the basic graphs of the trig functions. Our first one is y equal cosine x. Written over here, graph y equal cosine x, and I thought we'd make a little table to begin with where x is in increments of pi over 4, and then we'll write the corresponding values of y equal cosine x. I know when x is equal to 0 that cosine of 0 is 1. When x is equal to pi over 4, which is 45 degrees, cosine of x is going to be equal to 1 over square root 2, which is about 0.7.
So about this table, I forgot to mention that I did posted the value, like the table value for like this special angle in Canvas in a module. Let me see module. I think in module 1. So you can click at trig unit circle picture. So you can figure it out on your own by looking at this picture. So this picture including a radian and the degree of the angle. We have sine theta, cosine theta, tangent, cosecant, secant, and cotangent. So you can figure out a value on here. If you cannot memorize, I don't force you to memorize it, but you are welcome to look at this table and figure it out where is where. So you also can convert the, for example, square root 3, you convert into decimal number and then divided by 2, you got a decimal number so that you can plot on the graph easier. Okay, so but for me, you just need to mark just the basics one. I don't want you to um, like spend too much time to plot all of it. All of this like from 0 to 11 power 6, something like that. You can pick some special value like 0, pi over 6, pi over 4, pi over 3, pi over 2, and then that's it. Um, or it depend on the problem, maybe pi and 2 pi, stuff like that. So 2 pi go back to right here, okay? 0 or 2 pi. So just give me the special angle, that's enough to graph. Otherwise, then you're welcome to plot as much as you can to make the graph more specific. And here is the unit circle that I feel like you will need this because right here they have radian, they have degree, and they have the value of sine, cosine, and psi, or x comma y. So this is the value that like right at if, for example, right here, if I have cosine is 60 degree and my value, the answer would be 1/2. Or sine of 60 degree, my value will be square root 3 over 2. Something like that. And you're just moving along like all the whole circle. Okay, so let's go back to the lecture right here. So that's why how we have the facts. So this is all the value facts that you can graph on your work. So another word, you can take pi as 3.14 divided by 4. Okay. However, so when you are, but here is a radian. So you have to plug in for pi over 4 into cosine of pi over 4. You got square root 2 over 2. You can convert square root 2 become a number divided by 2. You got 0.7 and so on. So like I said on a graph, you might write like 0 pi over 2 pi 3 pi over 2 and 2 pi. That's good enough for me, but again, it's up to you. Okay,
When x is equal to pi over 2, cosine of pi over 2 is going to be 0. When x is 3 pi over 4, I know I'm in quadrant 3. The reference angle is pi over 4, so I know I'm going to get my 0.7. And then since I'm in quadrant, did I say 3? I'm in quadrant 2. I know cosine is negative there, so negative 0.7. At pi, cosine of pi is going to be negative 1. Cosine of 5 pi over 4 is going to be negative 0.7. Cosine of 3 pi over 2 will be back to 0. Cosine of 7 pi over 4, 7 pi over 4 is in quadrant 4. Its reference angle is pi over 4, so the cosine is going to be 0.7, and in quadrant 4, cosine is positive, so it's positive 0.7. And then, of course, cosine of 2 pi is going to be back to 1. So I'm going to graph these ordered pairs. X equals 0, y equal 1. That's right here. X equal pi over 4, y equal 0.7. So here's pi over 2. Halfway to there is pi over 4. And so I'm going to say this is about 0.7 right here. At pi over 2, y is down to 0. At 3 pi over 4, which is right here, I'm down to negative 0.7. At pi, I go out to negative 1. Then back to negative 0.7, up to 0. At 7 pi over 4, y is equal to 0.7 again. And then at 2 pi, y is equal to 1. So if I connect these points with a nice smooth curve, I get one complete cycle of y equal cosine x. Now, the amplitude of this graph is how high or how low the graph goes. It's halfway between the highest point and the lowest point. This graph has an amplitude of 1. And then the time it takes for it to go, the length it takes for it to go through one complete cycle of all the values of y it's going to take on the x-axis, that's called the period of this graph. So this graph has a period of 2 pi. So this is my basic y equal cosine x graph. If I want to extend beyond 2 pi, I know I've gone from 0 to 2 pi for x. As I go farther on here, I'm just talking about angles that are coterminal with my original one, so I'm going to sketch out the same basic shape in both directions. I'll just keep continuing to put one complete cycle down. Now let's look at our second problem. Second problem, we're asking find x if cosine x is negative 1 over square root 2 and x is between 0 and 2 pi. So what I'm saying is that the cosine of x is negative 1 over square root 2 or negative 0.7 and x is between 0 and 2 pi. Well, if I go over to the graph to about 0.7 on the graph, negative 0.7, which is negative 1 over square root 2, and then I'll just travel along the graph in a straight line and see where my straight line intersects that graph. It intersects right here, which is going to be x equal 3 pi over 4, and it intersects right here, which is x equal to 5 pi over 4. So cosine of 3 pi over 4 and cosine of 5 pi over 4 are both negative 1 over square root 2, and those are the only two values of x between 0 and 2 pi that that's true for. So here's my answer to that question, 3 pi over 4 and 5 pi over 4. So once we have the graph of y equal cosine x, we can use the graph to find some values of x given certain values of cosine x. Let's look at another problem. It says give the amplitude and period, and I've got a graph that looks like this. Okay, so that goes through one complete cycle. It's a sine curve. It has an amplitude of 3. That is the average or halfway between the highest point and the lowest point. That's a total of 6. Half of that is 3, or it's just the height of that hill and the depth of that valley. So the amplitude for this graph is equal to 3. And then the period is the distance on the x-axis it takes to go through one complete cycle. Well, here is a length of pi over 4 and another 3 pi over 4. So 3 pi over 4 plus another pi over 4, that gives me 4 pi over 4 or pi. So that graph has a period of pi and an amplitude of 3. I'm going to walk over to the board now and work another problem. Here we have graph y equals 6 sine x, and I notice this coefficient 6 is going to change the amplitude of this graph from the graph of y equals sine x. So I'm going to begin by just sketching the graph real quickly of y equals sine x. I know when x is 0, sine x is 0. When x is pi over 2, the sine of x is 1. When x is pi, sine x is 0. 3 pi over 2, sine x is negative 1. I'll put that right there, and then back up to 0. So a quick sketch of y equals sine x will look like this. Now I'm just using that for reference because when I look at this equation, I see that this coefficient 6 is going to change each value of y from this equation. So where here I have y is equal to the sine of x, this is going to be y equals 6 times the sine of x. So where this red graph is 0, 6 times 0 will still be 0. When I get out to x equal pi over 2, I see that y is equal to 1 here on this graph. So y is going to be equal to 6 times that on this graph. So when y is 1 here, y is going to be equal to 6 over here. Now I drop back down to y equals 0, and 6 times 0 is 0. When x is equal to 3 pi over 2, y is equal to negative 1. 6 times negative 1 is negative 6. So that'll be down here. So if I multiply each of these values of y by 6, I'll get a graph that looks like this. This is just a quick, rough sketch of that graph. So you can see y equals sine x has an amplitude of 1. It looks like this. When I multiply each value of y by 6, I get a graph that looks like this, and I say this is a sine curve with an amplitude of 6. Okay, I want to work another problem. Problem 5, I have y is equal to 1/2 cosecant x. And notice that I've graphed here in green the graph of y equals sine x. It goes from 0 up to 1 when x is pi over 2, back down to 0, then down to negative 1 when x is 3 pi over 2, and then out to 2 pi. Now what's in red is the graph of its reciprocal, or y is equal to cosecant. Oops, let me get that right. Cosecant x. That's what I have in red, and that's the reciprocal values of y that you see here on the green graph. When x is equal to pi over 2, sine x is 1, the reciprocal of that is 1. So over here for this graph, when x is equal to 30 degrees, y is equal to 1/2, and so its reciprocal is going to be 2. Now the graph I'm looking for is the graph of 1/2 cosecant, so that's going to be a graph that has y values that are 1/2 of all these y values. So if I just look at my red graph here, and I take 1/2 of all these y values, I'll have the graph of 1/2 cosecant. So when y is equal to 1 right here, half of that is going to be 1/2. When y is equal to 2 up here, half of that is going to be 1. I'll have that. And when y is equal to 2 up here, half of that is going to be 1. And the higher up I go, half of each of those things is going to drop it down a little bit. So if I sketch this graph that looks like this, these y values are all approximately 1/2 of these y values right here. So I can get the graph of y equal 1/2 cosecant by first graphing my cosecant curve and then taking 1/2 of all those y values. Let's look at this part of the graph here. I'll use the same idea. When y is equal to -1, half of that is -1/2. When y is equal to 2, half of that is, when y is equal to -2, half of that is -1. And over here, when y is equal to 2, half of that is, again, -2, half of that is -1. So here, this part of the graph is going to look like this. So what's nice about graphing this way is that we have a basic graph right here, and we look at this coefficient, and we know how it affects the graph. It saves us from making a table. If we know what y equal cosecant looks like, then we certainly know what y equal 1/2 cosecant looks like. So a quick look at some graphing of the basic trig functions plus some amplitude.
So all of the formula for amplitude and period I have posted in the extra notes, or you can read from textbook or the summary. The amplitude.
Next, we want to look at some of the.
So the amplitude all the time will be like the value in front of the function. Like for example, right, for y equal to cosine of x right here, the amplitude is 1, absolute value of 1. Or you can write as, there's a formula, amplitude is a equal to 1/2 multiplied by the absolute value of the big the big magnitude, which is big M minus small m, which is the value that let me show you a bit so that you can not confusing. Let me go back to my notes. Let me see. I recommend that you read my the extra notes before you watch the video, okay? So I give you extra domain and range, and so how to grab it, and the formula for amplitude right here. So you can take a look at it. You got a function y equal to capital A times sine of b times x. Actually, this is just one of the example general formula, but we have more complex, relate to phase shift and relate to like combined function. So you will see it later. So right here it's just like a simple function. Y equal to amplitude or capital A times cosine of bx. The amplitude will be absolute value of A, and the period all the time. For sine and cosine, you will take 2 pi divided by b, which is the value in front of small x right there. And be careful when you are looking at the formula. So that's why I would like you to write somewhere. So here's the example that for you to read more and practice on it so that you can be good at it. I give you many, so I'll go ahead and practice on this example. And I would like to show you another formula. Let me see. So 4.3, 4.3 is, yeah. So this formula is y equal to capital A times sine of bx plus c. So this relates to phase shift and similar to cosine. And b should be positive, okay? And have the following characteristics. We have amplitude is absolute value of A. Period will be 2 pi. This apply for sine and cosine, okay? So if with tangent, so you will have different period, right? You have pi divided by b. Right here, we're talking about sine and cosine, so the period all the time you will take 2 pi divided by b. Value b is in front of x, and the phase shift will be minus c over b. Okay, and I would like to give you some more formula down here. Example. So here is another formula that we combine y equal to k plus a times psi times b times x plus c parentheses. So actually, for this, you can again follow the formula. Then you can find all of the information plus let me see. Look at the graph and figure out the equation. And I have the combine. This is the combine function, chapter 4.5. And we having, that's the combine function as well. We have inverse trig. Actually, I recommend you read this. Okay, read this before the lecture. But even though in the lecture they mentioned about that already, however, like I just afraid it's quick mention. But when you read ahead, you know, like and when you can read a summary so that you can get familiar to the information, and it will help you understand this better. For those who like never know trig, then you should do that way. For those who already know it, you know just watch the video first, then quickly catch all the important information, like the example how to do this, by the way, then you'll be okay.
The basic graphs of the trig functions. Our first one is y equal cosine x. Written over here, graph y equal cosine x. And I thought we'd make a little table to begin with, where x is in increments of pi over.
This is 4.1. And jump to 4.2.
In this section, we look at how changes in some of the coefficients in the equations for the trigonometric functions affect the amplitude and periods of the graph. First problem I've written over here is graph 1 complete cycle of y equals 6 sine x. So we know that this coefficient tells us what the amplitude is. So this graph will have an amplitude of 6, and then the coefficient here in front of x tells us what the period is. So the period will be equal to 2 pi divided by this coefficient, which is 1, so that's 2 pi. So I have a sine curve with an amplitude of 6 and a period of 2 pi. That graph is going to start at the origin. At pi over 2, it's going to be up to 6. At pi, it'll be back down to 0. At 3 pi over 2, it'll be down to negative 6. And at 2 pi, it will be at 0. So I can sketch the graph of that curve real nice and neatly like this, going through those points. So that's a nice quick way to sketch the graph of these trig functions if we just look at the coefficients and then identify from them the amplitude and the period. Here's our next problem. Let's sketch the graph of y equals sine 2x. Now in this case, the coefficient of sine is 1, so I have an amplitude of 1, and this coefficient here will give me the period. The period is going to be 2 pi. Whoops, let me get that right. 2 pi divided by this coefficient 2, which is just pi. So this graph will be a sine curve. It'll go through one complete cycle in pi units on the x-axis, and it has an amplitude of 1. So it's a sine curve. It starts at 0. It's going to end pi units later here at 0. Halfway between, it'll go through 0. And here at pi over 4, it's going to be up to 1. And at 3 pi over 4, it's going to be down to negative 1. So by comparison, that graph is going to look like this. So you can see, if I extend this graph, that it's going to look like this. Just so you can see what this coefficient 2 tells me is that this sine curve is going to go through 2 complete cycles in what was one period of 2 pi. So if I take the old period 2 pi and divide by 2, I get the new period for this function. So 2 pi divided by 2 is pi, and you can see that that graph goes through one complete cycle, pi units on the x-axis. Here's our next one. Y equal 1/2 cosine 3x. I want to sketch the graph of this. Okay, it's a cosine curve. It has an amplitude of 1/2, and it has a period of 2 pi divided by this coefficient 3, which is 2 pi over 3. So it's going to go up to, let's see, I'll call this 1/2 on the y-axis, and this will be negative 1/2. It's going to have a period of 2 pi over 3, so I'll put 2 pi over 3 out here. It'll go through half a period, and half of that, which is pi over 3. Half of that will be pi over 6. So I have 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2. So this is going to be a cosine curve, so it will start up at the amplitude of 1/2, come down to 0, go down to negative 1/2, back up to 0, and then back up to 1. So if I sketch one complete cycle of that cosine curve, it will look something like this. So a nice quick way to sketch these curves is just identifying these coefficients here and how they affect the amplitude and period of the graph. Our next problem is taken from the problem we just did. Let's sketch the graph of negative 1 plus 1/2 cosine 3x. Well, I already have my 1/2 cosine 3x right here. So all I want to do to each of these values of y right here is add a negative 1 to them. So where I did have 1/2 for y, when I add negative 1 to it, I'm going to end up with negative 1/2. Where y was 0 right here, when I add negative 1 to it, I'm going to be down to negative 1. And where y was negative 1/2, when I add negative 1 to it, I'm going to be down to negative 3/2. When y was 0, when I add negative 1, I get negative 1. And when y was 1/2, when I add negative 1, I get negative 1/2. So that curve will look like this, and it should look like my original graph, just with all the values of y brought down 1 unit. And it does look like that. They sort of parallel each other like this. This graph is simply, the black graph is simply 1 unit below the red graph. So a little variation on graphing with amplitude and period.
I hope it's simple enough for you to understand how to graph quickly, basic. Let me move on to actually the part that we'll not go over with that. You don't need to worry about it. Okay. That is 4.2. Let me see. This is 4.2 and 4.3 about phase shift.
We want to add phase shift to the properties of the graphs of our trigonometric functions. And let's look at our first example. We want to graph y equals the sine of x plus pi over 4. And I've written down here the graph of y equals sine x, so we can compare it, this curve right here, with the graph of y equals sine x plus pi over 4. So you might just ask yourself here, what would it take in here to make that 0? Because I know that when I have 0 right here, the sine of 0 is 0, and that's kind of like where the graph starts. So if I say, well, what will make this expression 0? The answer is negative pi over 4, and that also is the phase shift for this graph. That phase shift is equal to y is equal to negative pi over 4. So when my graph would normally start right here, this graph is going to start at pi over 4. So all of these points on the graph are going to be backed up pi over 4 units. So where that was right there, it's going to be back pi over 4, and where that was right there, it'll be back pi over 4. So my graph is going to look like this. And some people like to say, well, the graph of y equal x plus pi over 4 leads the graph of y equals sine x by pi over 4 units. So you can see the phase shift right here, negative pi over 4. The graph starts at 0. The sine curve starts at 0 at negative pi over 4 and then goes through one complete cycle. One complete cycle hasn't changed. It's still 2 pi units. Let's try another one. Y equal negative cosine 2x plus pi over 2. So the negative sign here tells me that the graph is reflected. This coefficient right here, 1, tells me that the amplitude is 1. This coefficient tells me that the period is going to be 2 pi divided by 2, which is pi. And then the combination of this coefficient and this constant term right here will give me the phase shift. So my phase shift is going to be the opposite of this number, pi over 2, divided by this number, 2. So pi over 2 divided by 2, that's going to be negative pi over 4. So my graph is going to start at the phase shift, which is negative pi over 4. It will end pi units later. So it will end at negative pi over 4 plus pi. So negative 1 pi over 4 plus 4 pi over 4 is going to be 3 pi over 4. So let's see. It's going to have an amplitude of 1. So I'll just make this 1 and this negative 1 on the y-axis. It's going to start at negative pi over 4. So let's put that right there, negative pi over 4. It will end at 3 pi over 4, which is pi units after where it starts, negative pi over 4. So if this is 1 pi over 4, then this is 1, 2, 3 pi over 4. So that's 3 pi over 4. This is 2 pi over 4, which is pi over 2. And this is just going to be pi over 4. So let's see. I have a cosine curve. It's reflected. So instead of starting at 1, it's going to start down here at negative 1. It's going to go through one complete cycle in pi units. So I'm going to go from 1 to 0. Sorry, from negative 1 to 0 to 1, back down to 0, and then down to negative 1. So I should get a curve that looks like this, something like this. This is a nice cosine curve. Has an amplitude of 1. It has a period of pi units on the x-axis. It has a phase shift of negative pi over 4, and the graph's reflected about the x-axis. So put all those things together, really pretty easy way to graph this fairly complicated looking function just by knowing what these two coefficients do, and then that constant term also. Let's try one more. Y equal 4 cosine 2x minus pi over 2. Okay, I have an amplitude of 4. I have a period of 2 pi divided by 2. That's that coefficient there, which is pi. And then I have a phase shift of negative pi over 2 divided by 2. So it's negative c over b. So I have negative pi over 2 over 2. That comes out to be positive pi over 4. So I'll put all those things together, and I'm going to say my graph will start at pi over 4. It will end pi units later at pi over 4 plus pi, which is 1 pi over 4 plus 4 pi over 4, or 5 pi over 4. So let's see, I'm going to go in units of pi over 4. So let's say 1, 2, 3, 4, 5. 5 pi over 4, 1 pi over 4. If I want to know what point is halfway between, I will average these two. So I'll add them together. Pi over 4 plus 5 pi over 4 is 6 pi over 4, and divide that in half. So this will be 3 pi over 4. 1 pi over 4, 2 pi over 4, so that's pi over 2. 3 pi over 4, 4 pi over 4.
Or you can take pi over 4 plus 3 pi over 4, then divided by 2. Okay, and as same as to get the point in here, you take 3 pi over 4 plus 5 pi over 4, you got 8 pi over 4. 8 pi over 4, you divide by 2, you get the solution for this middle point.
4, which is pi, and then 5 pi over 4. Okay, the amplitude is 4, so I'll make that 4 on the y-axis and that negative 4. Let's see, again, I have a cosine curve. It's not reflected, so it's going to start at the phase shift of pi over 4. Regular cosine curve starts at 1. goes down to 0, down to -1, back up to 0, and then up to 1. So my curve is going to look like this. Nice cosine curve. One complete cycle goes through. It takes pi units on the x-axis to go through one complete cycle, has an amplitude of 4, has a phase shift of pi over 4. Now, if I wanted to extend this graph in either direction, it would be very easy to do that. I could just come back here like this, come down like this, and I can extend that graph as far as I want in either direction. Once I have one complete cycle, I have as many cycles as I want.
However, like you can extend it when they don't give you any interval. But if they do give you interval, for example, it's only from you know, pi over 4 to 5 pi over 4, then you only graph from that point to the end point, from start point to the end point. You don't do, or you know, you don't extend all the way. So be careful for the interval that you know, the homework give you, or the test will, you know, but I might give you on a test with the restricted you know, interval. Okay, be careful.
So that's a look at amplitude, period, and phase shift.
All right, class. And that is 4.3. Let's see. Uh, 4.4. Excuse me.
Next, we want to take a look at some graphs and see if we can find from the graphs the equations that gave us those graphs. Here's our first one. This is a straight line, so a little review from algebra. I want to find the equation of this straight line. I notice that the y-intercept is 1, so I'm going to say that b is equal to 1, and then I'll just look for the slope, and I see that a run of 2 is always accompanied by a rise of 1. So the rise of 1 accompanied by a run of 2, so m will be equal to 1/2. I know the equation of any straight line can be written as y equals mx plus b. So this line must be y equals 1/2 x plus 1.
So for this type of, you know, looking at the graph and figuring out the equation, you don't have to, you know the slope that direction, you know, is a positive, right? So you know your slope will be a positive, so m have to be positive. So first, when you look at a graph, you look at the y-intercept first, which is in this case is 1. You know, b is 1. Okay, and for the slope, you should thinking about the formula for the slope is m equal to y. Y2 minus y1 divided by m2 x2 minus x1, or another word is rise over run. And looking like that, so for example, for this case, you can choose, okay, you can draw a bigger, you can choose a point right here. So let me annotate that. Let me see. Or maybe you can choose like the point, like for example at 4, that is easier for you to compute. Then you can choose that point and you know, draw all the right triangle. Maybe for over 1, for example, right here. Because it's kind of a light. It's not the number is not clear enough. So like for example, you can draw a very big value, you choose that point to this point, for example, then you can draw it and you take the y value divided by x value, you got the slope. Another word like here, so this the instructor choosing the value is right here. You go down, so it go down, it's like look like go down 1 unit, right? So from for example, maybe 2 right here. So this point is like at 2, 2, 2, okay? So and rise, which is 1 unit only, and run is like 1, 2 unit. So rise over run, which is 1 over 2. That's how you got it. And like I said, you can choose different point, different value to draw it to figure out rise over run. But you need to simplify as well.
And then if I wanted to, I could substitute some values of x in. get out the corresponding values of y, I'd have some ordered pairs that are solutions to this equation, and I could check to see that sure enough, their graphs would lie on that line. Let's look at a trig function. Here I have a graph of a trig function. I want to know what is the equation. Well, let's just look at the characteristics of this graph. First of all, I'm going to look at the amplitude, and I see that the amplitude of this graph is 3. That tells me that a, that coefficient that I use in my trig equations, a is equal to 3. The period of this graph, I know is always going to be 2 pi over that b coefficient, and in this case, I see that the period is 2 pi, so that means that b must be equal to 1. So I have b is equal to 1, a is equal to 3. Now there's no phase shift, it starts right here. I'm going to say that this looks like a cosine curve that's been reflected. Whoops. So the graph is a cosine curve that's been reflected, so it's going to be y equals, I'll put a negative sign in that will reflect it. Amplitude is 3, cosine of b times x, which is just going to be x. So here's my negative sign. That reflects the graph. The amplitude is 3, and the period is going to be 2 pi divided by 1, which is just 2 pi, and of course it's a cosine curve. So this graph right here comes from this equation, y equals negative 3 cosine x. Let's look at our next one. I have this curve, it looks to me like a sine curve, so I'm going to say, well, okay, this is a sine curve. So I have a sine curve. The amplitude, I'll check it. The amplitude is 1, so that tells me that a is equal to 1, so I have that coefficient. The period here is 2 pi over 3, so the period is going to be 2 pi, always divided by that b coefficient. In this case, for this graph, it's 2 pi over 3. That tells me that b is equal to 3. Now, anything else about this curve? There's no phase shift. So my curve starts right here, a nice sine curve starts right here, no phase shift, has an amplitude of 1, a period of 2 pi over 3. That tells me that b is equal to 3, and it hasn't been reflected, so it's pretty easy to write the equation. It's going to be y is equal to the amplitude 1 times the sine of b times x, which is going to be 3 times x. So y equal 1 sine 3x, or just y equal sine 3x would be the same thing. So here's this equation, here's this graph, and from this graph I found this equation. Let's look at our next one. This also looks like a sine curve, so I'm going to say, okay, this is sine curve. My amplitude is 4. So that tells me that a is equal to 4. My period is 2. I know my period is always 2 pi divided by b. That comes out to be 2. Okay, I'm going to have to solve this equation. I'll multiply both sides by b and end up with, let me take it down here, 2 pi is equal to 2b. So b must be equal to pi. I see I don't have any phase shift. The phase shift is 0. It's a sine curve that has not been reflected, so I can write the equation pretty easily as y is equal to, let's see, my coefficient a, 4 sine, my coefficient b, which is pi, times x. And sure enough, if I was to try to graph this equation, I'd say, well, it's a sine curve. It has an amplitude of 4, and it has a period of 2 pi divided by pi, which is the same as 2. So I see that this graph does have a period of 2, and that will come out of this equation. So here again, I've taken the graph of an equation, and from that graph, found the equation itself.
So we are finished 4.4, right? So we have 4.5 and 4.6, and we're done.
In this section, we're going to graph combinations of functions, and our first one involves a algebraic function along with a trigonometric function. Let's graph y equals 1 plus sine x. Now, we've done this kind of graph before, but we're going to look at it a little differently this time. I'm going to look at this as y equals y1 plus y2, where y1 is equal to 1 and y2 is equal to sine x. So if I graph y equals 1, that's just going to be a straight line that looks like this. It's about as straight as I can draw it right there. And if I graph y2 equals sine x, that's just going to be a sine curve. Now let's see, it's going to have a period of 2 pi, so it's going to look like this. There's one complete cycle. There's two complete cycles. So now what I want to do is add these two graphs together to get the graph of 1 plus sine x. So one thing I can say is that anywhere one of my graphs is 0, I'm on the other graph. So when I add these two values of y, 0 plus 1, I'll get 1. When I add these two values of y, 0 plus 1, I'll get 1. These two values of y, I'll get 1. These two values of y, I'll get 1. And these two values of y, I'll get 1. Where both graphs are 1, my red graph and my black graph are both 1 right here. When I add those together, I'll get 2. There's another place where they're both 1, so I'll add those together, that will be 2. At this value of x on the x-axis, one graph is 1, the other graph is negative 1. 1 plus negative 1 add to 0. I have another point like that right here, where I have 1 plus negative 1, that gives me 0. So if I connect these points with a smooth curve, I have the graph of the sum of those two functions. So my blue graph right here is the graph of y equal 1 plus sine x. A couple of different ways to think about this. You can think about it being the graph of y equals sine x moved up 1 everywhere, or you can think of it as the sum of y equal 1 and y equals sine x, and we just go add our y coordinates. Let's take a look at a little more difficult one. I have y equal 3 sine x and y equal cosine 2x, and I want to add those two together. So let's let y1 be equal to 3 sine x, and let's let y2 be equal to cosine 2x. So first, let's graph y1 equal 3 sine x. That's going to be a sine curve with an amplitude of 3. So it will start at 0. It will go up to 3, back down to 0, down to negative 3, and back up to 0. So I'll get a curve that looks like this. And here it's going to go back up to 3, down to 0, down to negative 3, and back up to 0. And like this. So there's the graph of y equal 3 sine x. Next, I want to graph y2 equal cosine 2x, which is a cosine curve with an amplitude of 1 and a period of 2 pi divided by 2, or just pi. So this goes through one complete cycle in pi units on the x-axis. So I'm going to start at 1. It's going to end up at negative 1 halfway, and then back up at 1. So that curve is going to look something like this. Okay, let's see if I can sketch that. Here's halfway. It'll look like that. Here's halfway, so like that. And then here's halfway, so. Okay, so there's my graph of y2 equal cosine 2x. Now what I want to do is add these two graphs together to get the graph of y equal 3 sine x plus cosine 2x. Let's try it. Like I said before, anywhere one of the graphs is 0, I'm on the other graph. So here I'm looking at my red graph, it's 0, I must be on my other graph. So I'll put a little dot there. Here my red graph is 0, so I'm on my other graph. Here my red graph is 0, I'm on my other graph. Here the red graph is 0, so I'm up here. And here the red graph is 0, so I'm up here. Let's look at where the black graph is 0. Here the black graph is 0, so 0 plus this value of y must be that value of y. Here it's 0, so I'm at that value of y. Here the black graph is 0, so I'm down to this value of y. 0, add those two together and I get that. This 0 plus this y is this y. This 0 plus this y is this y. Down here, same thing. And down here, the same thing. Now, let's see, at this value of x, my one graph is 3, my other graph is negative 1, so when I add 3 and negative 1, I end up with 2. Down here, this graph is negative 1, this graph is -3, so together they add to -4. Over here I have 3 plus -1 is going to give me 2. And over here I have -1 plus -3 is going to give me -4. So you can see that I have sort of an outline of what this graph should look like, the sum of these two graphs. So I'm just going to connect these graphs with a nice smooth curve, and I'll get the graph of the sum of those two functions. So, whoops, I should have been up there, right? Yeah. Okay, so it looks something like this. Now, this is really good enough for graphing by hand. If you graph this on a graphing calculator, or you do it on graph paper and do it a little more accurately, you'll see that the graph actually, this little part here is a little bit wrong. It should come down and then go back up like that. This is okay, but up here, it should go up, come back down, and then like that. But for the amount of accuracy I have drawing it here on the chalkboard, this is good enough. We just want to practice putting these two graphs together as best we can, adding our y coordinates up, and looking and see if we see a pattern between the points that we've drawn out, and then connect them with a nice smooth curve. So you might want to try this problem again on a graphing calculator, or maybe you want to try it on some graph paper drawing a little more neatly than I did here, and you might see this little part right here that I couldn't get with the accuracy that I'm doing on the board right here. But still, you get the idea behind graphing these combination of functions.
We did combining for function already, but like I said, you know, you just like roughly scan it, but at least give me like 1 or 2 coordinate on a graph, then it's be fine. And I will only give you the simple graph. I'm not going to give you a complicated one. Let's look at the last section. We're done for chapter 4.
Let's look at some problems that involve inverse trig functions. Our first one here says evaluate inverse sine of square root 3 over 2. Now this notation stands for the angle between -90 and +90 whose sine is square root 3 over 2. So if we say that to ourselves, we know that this angle must be 60 degrees in degree measure or pi over 3 in radian measure. So when I see this notation, I know that the angle I'm talking about has to be between -90 and +90, and its sine must be square root 3 over 2. Let's look at our next problem. Inverse tangent of 1. Well, the restriction on inverse tangent is also between -90 and +90, and I want the angle whose tangent is 1. Well, I know that that must be 45 degrees, or in radian measure, pi over 4. So the angle whose tangent is 1 that lies between -90 and +90 is 45 degrees, and then if you want it in radian measure, pi over 4. How about the inverse sine of -1/2? Well, inverse sine -1/2, the 1/2 tells me that I have a reference angle of 30 degrees. This inverse sine has to be between -90 and +90, so I'm going to say it must be -30 degrees, or -pi over 6. So that's the angle.
Oh, remember, is because psi is the odd function, so that's why we're keeping the negative sign.
Angle between -90 and +90 whose sine is -1/2. So this sign right here tells me what quadrant it's in. I have to know what the restrictions are on the inverse trig function. Sine and tangent are restricted between -90 and +90. Inverse cosine is restricted between 0 and 180, or 0 and 2 pi. Now, if you're using a calculator to do these problems, your calculator already knows that. Let's try one more. How about the tangent of the inverse sine of 3/5? Well, I'm going to say, let's let alpha equal inverse sine 3/5. Because that's all this is an angle. So really what I'm looking for here is the tangent of alpha. Now, what do I know about alpha? I know that its sine is 3/5. So just to help me out a little bit here, I'm going to draw a little right triangle, and I'm going to put angle alpha right here, and I'm going to label the triangle so that alpha has a sine of 3/5. So if I label that side 3 and that side 5, I have a picture of a triangle with an angle whose sine is 3/5. Now I know from the Pythagorean theorem that this side then must be 4. So the next question is then, what is the tangent of alpha? Tangent of alpha must be equal to the opposite side divided by the adjacent side. So that's going to be 3/4. So with a little diagram like this, and going back to our second definition for the trig functions that involve right triangles right here, I can get a little picture. The main thing that you need to know about this notation is it stands for an angle, a specific angle. In fact, in this case, the angle between -90 and +90, whose sine is 3/5. Sometimes we can just work them out in our head. Other times, maybe we let alpha equal that angle and then draw a little picture. It gets a little more complicated, then I could say tangent alpha is just 3/4.
All right. Every time
Let's look at some problems.
I'm sorry. Every time that you notice the number, you can draw the right triangle and then apply the SOTA to figure it out. Okay, so that for the last section in chapter 4. If you have any question, please let me know, ask your friend. And I'm sorry to mention about the tutoring center. Let me show you where to get the tutor as well. You go to our class, you see online tutor right here. You click online tutor and then you register for it. I think it's they just take just 1 or 2 steps and then you can get the direct tutor. Plus I also mentioned about tutor center. Let me see if we do have math underneath. I remember right here. Okay, even though they wrote like that, you can just click here and then ask the online tutor to help you if you want. Plus, let me see. I believe that's all for chapter 4. That's all for chapter 4. And okay, we're done for today. Chapter 5, I'll do next time. And let me see. Again, you should go back to the action note or the textbook, okay, or the e-text if you feel like you need more information. But I did pull out all the formula for you already. You are welcome to look at this and more example underneath of here or more from the textbook. And I believe each chapter I give you like, I think at least 50 question per chapter. So you make sure you do it every day, okay? Okay, class, I think we finished and I see you next time. Thank you very much.